Hello, welcome to this lecture on New Technology Programming 4 and TP401T. This is Learning Unit 5 that looks at agent mobility, and my name is Ntsako Baloyi, and I'll be taking you through this video lecture. Okay, I've spoken already in the previous video, I've hinted on the concept of agent migration or agent mobility. And this is what this lecture hopes to achieve. And at the end of the lecture, you should understand what mobile agents are and how to use them, highlight some of the key benefits and limitations of mobile agents, understand and explain the basic structure of mobile agents, as well as discuss the different types of mobile agent migration strategies. Okay. By the end of the lecture as well, I hope that you'll be able to then implement mobile agents. I believe I've already shared some video links on the practical aspect of agent mobility, and I hope you have had a look at those, because we'll obviously not be able to have time on this video lecture to explore the more technical side of agent mobility, and therefore I'll just be dealing with the theoretical aspects. Okay, mobile agents are basically agents, you know by now, that are quite autonomous and capable of roaming wide area networks. And therefore, that last part which says they're capable of roaming wide area networks tells you that they want to move. With that autonomy or freedom of autonomy, there is often a need to then move around. The transition with code, the core code, the data that code processes, as well as the current state of that particular agent or the state at which the agent is in. They cooperate with each other while performing duties on behalf of their users. And it's important for them to cooperate, because moving into new environments, they'll need to communicate with new agents, with other agents. They will need to know what other agents are doing so that they can leverage also the services offered by other agents. Some of the key characteristics that you already are familiar with from even lesson 1, is mobility, agent mobility, which is what we're dealing with here, and migration autonomy, which also, does tie into mobility. Cooperation, which again ties into mobility, and they can also possess all other features of non-mobile agents. But most importantly for mobile agents, mobility, autonomy, and cooperation are the most key characteristics. All right. So, what are some of the benefits of mobile agents? Asynchronous and independent processes is one of those, because once they've migrated to a new platform, mobile agents do not have to contact their owner in order to perform a task, because they have that sense of autonomy. They can just do what they are made to do even in a new environment. They're fault tolerant, meaning they can be able to address and aid with fault conditions by moving to an alternative platform where you find that there are issues with the current platform where they find themselves. So that helps them with the fault tolerance, really, because to be able to then move to an alternative platform, it speaks to mobility. Okay, so which then gives them that fault tolerant capability. Well, there's about a sea of data applications, and you need mobile agents that are well suited to applications that need to process large amounts of remote data, because they can go to the various systems and process data in different types of systems. So the mobile agents, because of the nature of their mobility, can move in up to different environments and systems to be able to perform their tasks. Well, the picture is not just rosy. There are also limitations to mobile agents, and one of those relates to scalability and performance. And this is particular because even though mobile agents reduce network load, they also tend to increase processing load. Okay? The other issue is with portability and standardization. Because, for you to be able to move around and communicate clearly with others, you have to be interoperable. And that means you must understand what other agents are saying, and they must understand you. So a common communication standard is required to ensure that clear communication. Simple example, imagine somebody speaking Portuguese, somebody speaking English, and they both have no background of the other language. Security can also be an issue, in that there are certain information security problems that one can encounter with mobile agents because of their mobility. So, even in real life, when you think about the more mobile you are, the more you expose yourself to security risks. And therefore, if agents land up in an insecure environment, then they'll effectively be exposed, right, and can be terribly manipulated. Remember, I said that there are three important things with mobile agents, and that is they have got code, that code would process data, and they've got a particular state, meaning in what state are they in? Are they in progress? Are they active? Whatever the case may be, you need to know the current state of the agent, because you need to save that state if you need to migrate it to another, for strong migration to another platform, in order for the agent to be able to proceed from where it stopped. Okay. When you look at process migration, basically a process is a program that is in execution. You'd know in Windows when you do go to Control Alt Delete and Task Manager, you then see processes that are in execution. Now, the transfer of an executing program between machines is what we call process migration. So whenever an agent moves from one machine to another, that is what we call process migration, particularly when that program was executing. If it was not executing, then it is not necessarily process migration, it's just agent migration. An agent itself is a process with code and state. So obviously, as you code agents, they'll have code, which is what you do, coding the agent, and then you'll have a particular state that the agent will be in if it's in execution, right? Agent migration can involve a number of stages. And these are important because before you can migrate an agent, you need to deactivate it in the current platform. You need to capture its state so that it can easily continue in the new platform where it's supposed to migrate to. You then need to transport the code to the new machine. I mean, this, by the way, happens over a network, and therefore it can also happen automatically. At the destination, a couple of things need to happen. You need to restore the agent state so that it can be able to resume the execution. You need to activate the agent for it to continue where it left off executing. As by way, for example, you have here the agent in the master computer that can then migrate to node 1, node 0, node 1, node 2. It can even come back to the master. But that just shows you that an agent can go to many different nodes to execute its tasks. I mean, some of the reasons why an agent could even leave its master machine could be because of resource constraints that inhibit it from performing its required tasks, and therefore it might want to move to a machine that has got more resources for it to can be able to then execute its mandated tasks. Okay, so some of the requirements for migration are the following. There must be a common communication language because agents need to communicate. There must be process persistence because you need to be able to store a particular state of the execution, and there must be a communication mechanism between the agents, different agents, basically. And you need to also ensure information security to protect the agents as well as the agent hosts. Okay, so simply put, a common communication language is important because agents can then be able to communicate both in their master machines as well as when they are migrated to other machines. So to have a common communication standard or language helps agents communicate effectively wherever they go. And you also need to be able to persist a state of a process to be able to resume it elsewhere. But you then need to address also issues of security because as they engage with other environments as well as other agents, they may be quite exposed. Different types of migrations. We've got what we call weak migration, which is more simpler as it does not need to save the agent state. So with this one, the reason it does not need to save the agent state is because when it gets to the new platform and the new container or the new environment, it will just start again from the beginning. It will just re-execute. Okay. So agent execution always restarts with weak migration. And a migration technique for code and object members is basically what is important. So you just require code and data. That's it. You don't require the state with migration because you don't save it. Whereas with strong migration, you add the third element. It's more complex because you will need to save the state, and to do that, you need to freeze the current execution. You migrate, and then you can restart the execution with the next instruction that you were due to execute before the freezing on the new side. And for that to happen, you need the code. the data as well as the state. So this with strong migration adds the state, which is in contrast to with migration effectively. Power, for example, strong migration is made up of code and state migration, whereas state migration itself will then be made up of execution. So I was saying strong migration is made up of code and state migration, whereas state migration is made up of the execution environment as well as the data environment. Okay. When you look at the data environment, you could have member migration, stack migration, as well as resource migration. Whereas when you look at that data migration is made up of member, stack, as well as resource migration, whereas the execution migration is made up of the program counter migration as well as the thread migration. But with a program counter, you can either have the initialization migration or the method migration, because remember, you might want to just restart the process, or you could just continue from a particular line of code where it had stopped executing from. Okay, then we've got two types of migration itineraries. We've got static and dynamic itineraries, and static ones are basically determined at agent creation time without any possibility of them being modified whilst the agent is executing. With the dynamic one, exactly as the name says, it can be changed effectively. So the dynamic itineraries are determined during agent execution according to the needs and desires of a particular agent. So in this particular case, you'll notice that the one is defined upfront and the other one can be defined or determined as the project, as the agent executes. It's quite easy. I mean, just by remembering the name, static and dynamic should just set you well. Okay, we've got intra-agent migration as an inter-agent migration. Now I'll talk about intra, which means within a particular platform, you could have migrations within a platform, for instance, from container to container. Whereas inter will be across different machines and platforms effectively. So with agent mobility, it's basically controlled via the method do move, and the parameter that you pass the do move method is the location or the destination where the agent is supposed to move to. Once invoked, this method initiates the process of moving the agent to the specified destination container. Because remember, here you are still within the same platform, you're just moving between containers. The majority of the code that you require to achieve this is located basically within the Jade.co.mobility package, and it will be very good for you to go through that and see some of the benefits you can derive from that particular package. Okay. Now, with the invocation of the do move method, you then forward the agent mobility service through the method move to its helper. The first action that the helper carries out is to change the agent state from active to in transit, because now it's supposed to move over. So it cannot still be running or active. So you need to change the state, agent state. And I think we've dealt with agent states in another earlier lecture. I think it was Learning Unit 2. And once you put it in transit, the agent can cease operating, or rather executing correct activity, so that it can be able to move over. So whatever it was doing, it will be suspended, and it will then locate within the platform, but to a different container. You can then specify operations to be triggered when the mobility process has started. To say, for instance, using a before move or after move, for instance, you can say this and that should happen before the move takes place, and this and that could happen after the move has taken place. And these are also methods that come with the J.co.mobility package. All right. So you can just modify those if you want something specifically achieved there. As we continue to achieve that transmission, it's important to then rely on Java serialization, because it is used to transmit an agent instance of a network connection. This you achieve by recursively recording the internal member values of the agent object into a byte stream. And once the agent instant has been serialized, it can then be transported to the destination container by means of a horizontal command. And when it gets to the destination, it is then deserialized and so that you can be able to recover the original agent object and continue with its execution. I mean, Java serialization is a traditional concept in Java, and I trust that many of you are already quite familiar with it, but this just facilitates the proper transmission of the agent so that you can get it on the destination in the form that it's supposed to be in, and you are able to then resume execution from there. Okay, now we'll talk about inter agent migration. With inter-agent migration, you need to rely on the inter-platform mobility service, which is a Jade add-on that has been created to provide platform-to-platform mobility of agents. Remember, I said that platforms can be in different machines, but sometimes can even be on the same machine. But this is quite different from the intra one, because there it was within the same platform but different containers that you were migrating. But with inter-agent migration, it is across platforms, which these platforms could also be, by the way, in different machines. I just want to emphasize that both intra and inter-agent migration, for both of them, I have provided video links already for you to already start looking at the code associated with same. That has already been provided a while back, so you should be able to find that on my tutor. The core mechanism of the inter-platform mobility service is the movement of agents between platforms using the FIPA ACL messages as the transportation medium. Now, messages then get sent between agent management systems of the endpoint platforms, because remember, agents are managed by the agent management platforms or other systems. Now, the two actions that are very important in this particular case is your move method as well as the power up method. It's obvious the one is just to enable you to move the agent over to another platform, and the other one is to restart the agent on the other side. Okay. And then FIPA request interaction platform is therefore used for inter-agent migration. Let's just look at the request that I've just spoken of FIPA. So you start at agent A and you request a move, and it goes into the agent platform, and then you send the request move to that particular agent, and then it requests the creation. And then it informs the agent platform for agent 1, which is step number 4. Once it has done that, the next thing that can then happen is that one could decide to either quit, all right, or request start. And once you have requested start, you can then also push a request start this side, and then you inform the original platform that actually the agent has started successfully on my part, or the request that has been started successfully. So remember, you need to first move the agent over, but because you do all of this through the platform, you need to always communicate. So you request a move through the platform, and then it will send it to the other platform. When it gets there, that agent will get created, and then you will inform the agent back to say, look, the creation was successful. And then once that has been informed, the next thing that will then need to happen is that you need to request the start. Okay, the request start will then trigger a request start this side, meaning you'll start that agent that has just been migrated. And once that is done, all that you need to do is to inform the agent platform, and then you can terminate that agent fully this side. You can quit the process this side, because that you're effectively saying that the migration was successful. Okay, so there are information security concerns with the mobility of agents, and some of these concerns at a very high level. There could be attacks from agents to the agents. So agents themselves, if you think of it. So if you think of this agent could cause an attack on another, particularly where you don't trust the platform or the environment where the agents are residing or are moving to. There could also be attacks also from agents to host. So you can have attacks agents to agent. You can also have attacks agents to host. So agents themselves can attack their hosts, as well as you could also have host-to-host kind of attacks. All right. So it's a rather host-to-agent kind of attacks, where you have, like here, you have a host attacking the agent because it's perhaps an unsafe platform where you are hosting the agent. Okay. Some of the examples of the attacks could be wiretapping, try and figure out that agent is communicating or is doing. One could abuse the resources as well as the data of that particular agent. One could invoke that agent continuously to try and get a kind of a denial of service kind of an issue, so that the agent is not ultimately not able to do anything. You could have spoofing and many others. So your typical information security kind of issues you can also do with agents. So with the denial of service one, you can imagine multiple requests coming at the same time or multiple communications being sent and flooded on a particular agent could result, through the directory facilitator, could result in the agent being disabled effectively, not being able to do anything or process anything. Okay, so when you look at basic code, basically for a simple migration example, you would have a container here, it's container 1, right? And then you then have the container ID of the destination. You want to, and that is just to create some variables that will contain the information that you want to handle. Then you want to initialize the destination object, and to do that, you'll set the name of that container that you have, the container name that you have just created. And remember, it was container 1 there. And then you can then change the agent state to move by calling the doMove method and giving it the destination, which in this particular case was the container ID that was created there. Okay, that is just a high-level example of how that can happen. And almost at the end of this video, just want to show you quickly how this agent migration would work. So you notice here that you've got a remote platform, which with inter-agent mobility, you then could have an agent migrating, for instance, from a main container or container 1 and migrating to this particular platform. And in here, typically, you're supposed to also have some containers as well. The other thing that could happen is with intra, it will basically be a move. So you can think of this, the OA agent at platform 1 having originally been in the main container, and it has actually been migrated to this container 1. That is basically what is happening here. But you'll see by now that this other platform is actually a remote platform that could be sitting on a separate machine in a separate country, and you are able to then migrate an agent. You can be able to migrate an agent from a platform here on any of the containers to a remote platform, which could be, like I said, even in a separate country altogether. And the risks there become inherent, basically. By way of conclusion, we've introduced mobile agents, what they are and how to use them, highlighted the key benefits and limitations of mobile agents, as well as demonstrated to you the basic structure of mobile agents. Further to that, we've discussed the different types of mobile agent migration strategies, as well as demonstrated the use of Jade and mobile agents. Okay. Next is an exercise. I'd like you to please take some time to go through. You can pause this video now to go through this exercise. And then after that, you can then check out the solution in the next page, which is there. This solution is just indicative, but it's got some core things that I would expect in a solution, but not word for word and not exactly. Okay. For instance, your common execution language, your process persistence, your communication mechanism between agents, security to protect agents. But then once you have elucidated those, you need to provide your own explanation in terms of what that means. Okay. And then we've got references that I'd like you to look at. Of course, the book is chapter 5, but there are also other supplementary references. And please do have a look at those. With that, I want to thank you for taking time to watch this video lecture. All the best. If you have any questions, do not hesitate to send me an email. Goodbye.